But before we step there, I just want to understand, how will you ever test string theory? And we know in advance that you have naysayers out there, physicists among them, who are saying you're diverting time, resources, graduate students, faculty positions to something that doesn't even classify as a legitimate scientific theory or hypothesis, because you need to be able to test it. So let me hear your response to that.
For any theoretical framework where you're trying to describe things, if there's a big intellectual leap, right, and for example, extra dimensions is a pretty big leap, you have to justify that with a payoff, right? For string theory, I would say the problem is a lot worse than it was for something like the prediction of the Higgs boson, because the energy scales are so massive to directly observe strings. So for me personally, I'm interested in trying to decide whether string theory is useful a lot faster than that in the point of view of my career. And I remain very agnostic as to whether that's the case. So what do I think is the sort of most direct way to those types of answers is that in string theory, many types of structure and results in physics are really intercorrelated. So it turns out that in something like the particle physics description of all the particles we know about so far, the standard model of particle physics.
So that's the organization of all the particles that we know.
And the point I was going to make in relation to string theory is that in something like the standard model, there's a lot of free numbers. So for example, nothing in that theory tells you what the mass of the electron is or how the quarks couple to each other. Now, in contrast to that, in string theory, if you found a solution in string theory that produced particle physics like we see in our universe, none of those numbers are free. They're all determined by the configuration of these extra dimensions and the structure of the theory. So it's a huge array of physics that you have to get right all at once. And here I've been talking about particle physics, but you also have to answer questions about cosmology and the large-scale structure and history of the universe. So how are you going to decide if string theory is wrong? I think that it's most likely that we would be able to say that the structures that we see in nature, we can argue that we either can or can't get the right sort of regimes of numbers and effects that we already know are there much more rapidly than we're going to build an accelerator to see a string. And then if you say, what happens if there were 6 extra dimensions, which happens to be the extra dimensions that we think needs to arise to give what we see in nature? Turns out there are 500 million configurations and counting that have been found so far.
So it sounds to me like what you guys are saying is we have this instrument, and on the instrument, there's a certain amount of notes that are just resident in the instrument.
It could be, and you want the one song that's yours. It's not useful if you find it unless upon finding it, you get other insights about the universe we're in.